A cricket bowler throws a ball without spinning so it travels on a straight path, and the batsman can easily determine the path of the ball and hit it for the six.
The bowler gets upset. Later after the match, he is thinking, loudly so we can hear his voice, about this at his home to find the solution to this problem.
In order to distract the batsman, I need to throw the ball in such a way that it travels on a curved path instead of a straight path to confuse the batsman.
But he thinks loudly so we can hear his voice that there should be a force or pressure working on the ball in the air to move the ball on a curved path.
How can I apply a force when the ball is in the air because it's not in my control now?
Then a physicist named Bernoulli comes to him and suggests the Bernoulli Principle, which says less the airflow, more the pressure.
So, if you can get airflow on one side of the ball more than the other side, then there would be more pressure on the side of less airflow, and there would be a net pressure working on the ball. Now, if there is a pressure, it means there is a force on the ball in the air, and the ball will travel on a curved path.
How can I increase the airflow?
You can spin the ball while throwing it. By spinning the ball, it will drag air with it, creating more airflow on one side.
This is how the bowler's problem was resolved by using Bernoulli's principle. Now the bowler goes to the next cricket match and throws the ball with a spin. The spinning ball drags the air with it, increasing the airflow on that side. If there is more airflow on the spinning side, there will be less pressure on that side. Because of this pressure difference, the ball travels on a curved path. This time, the batsman cannot predict the path of the ball and misses it. The ball hits the stumps, and the batsman is out.
Yes, I did it.
The bowler is very happy. Later after the match, he meets Bernoulli again to thank him for this technique.
Thank you so much for your help.
You're welcome. I'm glad it worked out for you.